we're going to start studying multiple tests to determine, we use these tests to determine whether a series converges or diverges. And before we do that, I'd like to make a summary here of things that we know so far about series and some particular series. So please bear with me as we go through these, because everything that we're getting ready to say in the summary is something that we use from now on in our discussion of series. So the first is about geometric series. And the geometric series is one of the form that we see here. And we know that what we're given is a geometric series converges if the absolute value of r is less than 1. And of course that means that r is between -1 and +1, not equal to either one. Under those cases, it converges, and the sum is, okay? If it's true that the absolute value of r is greater than or equal to 1, okay, if that's true, then the series diverges, and it doesn't have a sum. So geometric series are very important in that respect, because we can tell real quickly whether they converge or diverge, and not only that, what they converge to. Now, there are some different looks, and as if you recall, I mentioned early on, normally our series start at n equal 1, but for conveniences, here we start n equals 0 normally for a geometric series. But we can see a geometric series written in this fashion. We could say the sum from n equal 1 to infinity of a times r to the power n minus 1. And that would give us exactly the same result. Now, another different look is sometimes we don't see the separation between the constant a and the common ratio r. See, so here's an example of a geometric series that we don't see that separation. The sum from n equal 1 to infinity of 2/3 the fraction to the power n. Now, if we were to write that out, we could indicate or find out real quickly that this is 2/3 plus 2/3 being squared plus 2/3 being cubed, and so on in this fashion. And we might notice that we could write that as 2/3 plus 2/3 times 2/3 plus 2/3 times 2/3 squared plus, and we could continue in this fashion. And so we see here the a is 2/3 and the r is 2/3 as well. So that's an important type of concept to keep in mind, that sometimes geometric series are hidden from us a little bit or disguised. Not on purpose, but that's just the way they're written. Now, another important option or series is that of a telescoping series. And I'm not going to go into any detail here, but remember, with telescoping series, we can also, if we recognize that it is a telescoping series, we can tell pretty easily whether it converges or diverges, because we can find the actual partial sums, the nth partial sum, and we can take the limit of that nth partial sum and know whether we get a finite number or not. So telescoping series is another type of series that is very useful, that we know whether it converges or diverges, and not only that, if it converges, we can determine what it converges to. Now, another thing that we talked about previously was called the divergence test. And this test is a quick test about whether a series diverges, not whether it converges, whether it diverges. And that Divergence test says something like this. If we look at a particular series, consider the series, the sum from n equal 1 to infinity of a sub n's. If the limit of the terms, so that's the terms that make up the series, it's basically a sequence, isn't it? That the limit of the a sub n's as n approaches infinity is not equal to 0. If it's not equal to 0, then the series diverges. That's the sum diverges. So we got to separate the idea of the terms and the addition of the terms. So if the limit of the terms is 0, then the sum of the is not 0, then the sum of the terms is not finite. So that's a very quick way sometimes to tell whether a series diverges, not whether it converges, whether it diverges. So that's the only thing we're testing here. Now, a couple of important limits that we talked about. The limit as, and we did this actually in a previous chapter, and it applies here as well later down the road. The limit of x to the power 1 over x as x approaches infinity is equal to 1. And we did that when we were, when did we do that? Trying to stop and think now. It's when we visited or talked about L'Hopital's rule. Okay, now just note, all I'm doing is rewriting this. This is the same, x to the power 1 over x is the same thing as the x root of x. So the limit of the x root of x as x approaches infinity is in fact 1. And we'll use that later on. Another important one here is the limit, and this was done at the same time, the limit of the sum of 1 plus 1 over x, that sum raised to the power x as x approaches infinity, that limit is actually the number e. Now, something that we haven't talked about yet is called the tail of a series. And so what I'm going to do on the next page is discuss the tail of a series, just so that we have some idea of what that is and the significance. Tail of a series. And remember, a series is an infinite sum. And based on that infinite sum, a tail, there's many tails, a tail is when we disregard some first finite amount of that series, and the remaining infinite terms are, that's called a tail. Okay, it depends on the book that you read and so on, whether this terminology is used, but I certainly do use it. So, so I would like to put here tail of a series versus convergence or divergence of that series. Convergence / divergence. So let's consider the series, okay, for the series. The sum from n equal 1 to infinity of a sub n's. Now, consider writing this out, okay? Consider that that series looks like a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, and this continues forever, doesn't it? And let's just, for discussion purposes only, let's say up to a sub 73 plus, now the next one will be 74, wouldn't it? Well, why don't we do this? the sum from n equals 74 to infinity of a sub n. So you can see I've written out the first 73 terms and then plus the infinite sum from 74 to infinity. So that's the rest of the terms. This is called a tail. A tail of the series from n equal 1 to infinity of the a sub n's. And so you can see there's any number of tails. We could have gone to only 16 and had the sum from 17 to infinity. That would be a different tail. So a tail is an infinite sum disregarding some first finite part of the series. Now here's the issue. That the convergence or divergence of a series is the same as the convergence or divergence of a tail. That is, if this sum from n equals 74 to infinity converges, then the whole series converges, because outside of that infinite sum, we're just adding a finite number of terms. And so we would take a sum plus an infinite sum that adds to a finite value, and add a finite number more of terms to that, which would be a finite value. On the other hand, if the tail diverges, that means it adds up, it does not add to a finite number. Then if we add a finite number to something that doesn't add to a finite number, then that will also diverge or not add to a finite number. So the convergence of the tail, the convergence or divergence of a tail is identical to the convergence or divergence of the original series. Let me state that. As I was writing this, it occurred to me that I need to be real careful to explain a little bit more. So the convergence or divergence of any tail of a series is identical to the convergence or divergence of the original series. Now, what I'm referring to here is whether a tail or series converges will be identical. Whether the tail or a series diverges will be identical. Okay, so they either both converge or both diverge. Now, in the case of convergence, a tail will converge to a different number than the original series, because a tail is not adding up all of the numbers, it's adding an infinite number of them, leaving out a finite number. So we have to be a little bit careful in the interpretation of this. Let me write one more thing. So in a restatement of what I just said, in the case that we have a tail and the original series, and we know that we have convergence of one, then we know we have convergence of the other. But it is important to know that each of the tail and original series will converge to different sums. They both converge, but they'll converge to different sums. Well, this is what we should know at this point about series. Now, like I said, what we're going to start on the next page is a test called the integral test to determine whether a series converges or diverges. It's a different test for different kinds of series that we haven't dealt with before.